Operational excellence is something all manufacturing organizations search for. Lean Six Sigma delivers operational excellence, but you can't just stop there. You keep a high level of operational excellence by continuously improving. Don't just improve in a business-driven direction. As you approach operational excellence, so should your suppliers. Your most strategic suppliers should be able to decrease supply costs year over year. Lean production replaces mass production in the 21st century, just like mass production replaced craft production in the 20th century. It focuses on the customer, builds a system around manufacturing, and minimizes the cost of inventory. Once you have standardized all your processes, it is important to audit the adherence to that standardization. It's possible to continuously audit. I'm Jim Fitzgerald, a Lean Six Sigma Master Black Belt, and will lead you on this journey. Next, we discuss manufacturing in general. I usually don't read slides, but the next two are so important I will read them. Manufacturing businesses face immense pressure to cut their costs and feel competitive pressures from overseas. Manufacturers do not manage their environment as a system, but as an assembly line. Automation seems to be a solution, but be careful or you might end up like Tesla. You may over-automate. Anytime you automate, you lock in performance. Leadership is not moving you towards Six Sigma as Motorola did decades ago. Assembly lines have an inherent inertia to change. This leads to manufacturing business that is static and living with whatever the assembly line delivers. Implement the Toyota production system that includes every entity from suppliers and customers. The Toyota production system is way more than just Lean Six Sigma. Though you start with the benefits of Lean Six Sigma, which guides you to excellence in manufacturing. This leads to a manufacturing business that is ever improving, agile, and robust. These 4 steps represent the path towards operational excellence. The journey starts with educating your staff on what is valuable and what is not within the manufacturing line. This allows you to make trade-off decisions as you improve manufacturing flow. The next critical step gives you profound knowledge of your production line and gives you information about the performance of every process within the manufacturing line. Once you understand the performance of your value stream along with every process within that value stream, it's time to start improving. Where you can, implement flow. Where you can't, implement pull. Continuous improvement is the unknown secret of Toyota. Toyota's program generates about 1 idea per month per person, focused in a business benefiting direction. Let's define value by looking at what isn't valuable. DOWNTIMES is the acronym that Lean Six Sigma uses that points to non-value-added activities. Since non-value-added activities represent 80 to 90% of activities, removing them is the easiest way to quickly improve. By learning this, employees become aware and performance increases. This does 3 things. 1. Removing activities that don't add value to a process increases the velocity of that process. 2. Quality increases when less actions are performed on any product. And finally, 3. Cost decreases as less work is performed. Your manufacturing line increases value as flow increases. Removing defects increases operational efficiency. I was discussing this with my niece the other day. She validates contract performance for the Navy. She told me that her suppliers are generally operating at 2.5 sigma. 2.5 sigma means that 1 to 2% of the parts you produce are defective. Let's talk for a moment about defects. Can you detect all your defects? Defects are only measured if you or your customer catch them. Also, there are defects that kill the product and ones that don't. Some defects are visible and some are buried within the product. Lastly, if your defects aren't distributed normally, sigma has no value. If your performance improves from 2.5 to 3.5 sigma, then you produce about 1/7 of the defects as you did before. If you move from 2.5 sigma to 4.5 sigma, your defect rate decreases from 118 2.5 sigma defects to 1 4.5 sigma defect. Generally, you detect a defect using quality control. Quality control is considered cost of quality. As the number of defects decreases, so should the cost of quality control. I want to make an important point here. Toyota has as many quality control engineers as they have employees on their assembly line. Every employee is required to stop the manufacturing line if they detect a defect. Slowly but surely, they rid their plant of defects. Toyota balances the number of defects against their rate of assembly line improvement. Creating a manufacturing line that constantly improves requires guiding principles. The following 14 principles are used by Toyota. Every business should create their own principles. Principles assign responsibility and goals. Review those at your leisure by pausing the presentation. Profound knowledge of your manufacturing performance is done through a value stream. A value stream follows your manufacturing value add, starting with the customer order through every value-adding process and finishing with customer delivery. This profound knowledge of your manufacturing line gives you guidance on where to apply performance improvement efforts that lead to the greatest positive impact. Once you have obtained profound knowledge of your value stream performance, it's time to improve it. The mantra is flow where possible, pull everywhere else. This value stream example is of a city building permit process. The solution includes flow from customer submission to the first in, first out buffer. Pull is what the building permit employees do to access the next building permit request. Now let's take a quick preview of the best continuous improvement program around. Toyota's continuous improvement program generates 11 ideas per person per year. This amounts to near continuous change. They not only change, but change moves in a business benefiting direction. Your current condition and your vision are challenged to find the improvement trajectory. That is progressed forward by passing through multiple target conditions. A challenge usually takes 2 to 3 years. Attaining a target condition usually takes about 2 weeks. When you advance towards a target condition, you can visualize the initial steps. Those steps take you to the knowledge border. Progression to the target condition past the knowledge border requires ingenuity. A vision or challenge at Toyota can be requested by anyone. The management structure and the underlying communication methodology is left for future discussion. Think of suppliers in terms of 3 tiers. The first tier is non-strategic. The third tier is very strategic. And finally, the second tier is in between. The third tier suppliers at Toyota are considered partners. They deliver just in time, are responsible for quality, and are able, with Toyota's help, to decrease cost over time. The relationship with third tier suppliers is strategic. Now let's discuss lean production. I only have a short time here to discuss lean production. Lean production is a system approach to manufacturing as opposed to a department focused manufacturing. The lean production system includes every manufacturing touch point from customer and supplier to product delivery. Customer orders initiate production and the assembly line is constantly improving. The audit lifecycle goes through what I call SLAT, which stands for Standardize, Live, Audit, Improve. This process enables you to perform near constant ISO 9001 audits, though ISO 9001 includes extra structure. The question with ISO 9001 is, does that structure deliver a good ROI? First, you standardize on what is best practice, then document the standard and post it so management can view it as they walk by. By living it, you will be performing operational testing and validating executability. Your manager then comes by and visually follows your documented activities to determine if the posted standard is followed. At this point, you should already be continuously improving the process. Let's discuss manufacturing metrics next. The first 4 metrics are all contained on your value stream map. Tack time is the rate of customer demand. VSPR is the rate that your assembly line produces a product. Ideally, VSPR should be slightly greater than tack time. Metric 7 is a quality metric and metric 8 is a performance metric. Lean Six Sigma drives operational excellence into any organization. Pull a line with a sorter connects the manufacturing line to your customers. Toyota assembly lines are usually stopped about 900 times a year to chase down defects. If there is too much change, the number goes up. And if there's not enough change, the number goes down. This is something to balance continuous improvement against. I'm Jim Fitzgerald, a Lean Six Sigma Master Black Belt, and look forward to moving your manufacturing business past 2.5 Sigma to 3 Sigma, then to 3.5 Sigma, and then maybe to 4.5 Sigma.